Hey guys, the purpose of this lesson is to look at how to write a linear equation using a slope or a y-intercept. So, by the end of this lesson, you'll be able to do that from a table, a graph, or a set of points. So this will be mostly a review for you guys. We did this in Foundations if you were in Foundations with me. We also did this in 8th grade or when you were in 8th grade math if you didn't take Foundations. So most of this will be familiar, hopefully, and not completely brand new. But it is important that you learn it. It's also important for state tests. It's important for ACT. This shows up quite a bit in that. So you'll want to make sure that you're paying close attention to the things that are being taught in this particular lesson for that reason. So, first thing we want to know is the parts of a linear equation. And hopefully you remember that linear equations are all written in the form y equals mx plus b. And so when you write them in that form, you replace the m and the b with numbers. And the m gets replaced with whatever your slope is, or your rate of change. And your b gets replaced with your y-intercept, or your initial value. So you should know that well enough that if I gave you an equation, don't write this, equals 2x plus 4, you can immediately tell me that the slope of this would be 2 and that the y-intercept would be 4. So you need to be able to be familiar enough with the parts of a linear equation to be able to do that very, very easily. It's very important that you're able to identify those pieces from that. So m is the slope, b is the y-intercept. If you know a slope and a y-intercept, you can very easily put an equation like that together. And so that's what we're going to focus on today, how to find the slope, how to find the y-intercept, so that you can create those equations when you need to. Y equals, so slope we remember is a measure of the rate of change of the function. Now change means it's not staying the same, it's changing, right? So change can be in the form of increasing or decreasing. So slope will tell you how much the function is increasing or decreasing over a particular unit of time. Now there are a couple of ways we find slope. The most common way, the one that most people remember the easiest, is to divide the rise of the function by its run. And we'll look at that on a graph. Now sometimes you could also be falling, but we call it rise over run. If you're falling, it ends up being negative. Now, if you're given 2 points, or if you're given a table, you could use the slope formula to find your slope. And that slope formula looks like m is equal to y2 minus y1 over x2 minus x1. So you subtract your y's and you subtract your x's, and then you divide the change in the y by the change in the x. Sometimes they refer to that as delta y over delta x. That just means the amount the y changes divided by the amount the x changes. And this is really kind of what we use when we're looking at it from a table perspective. We look at how much did the y's change, how much did the x's change, and then we divide the change in the y by the change in the x. All right. Then you also have to be able to identify a y-intercept. Y-intercepts are really easy to find if you're looking at a graph, because a y-intercept on a graph just represents the value where the graph, or where the line crosses the y-axis. It's also the y value when the x value is equal to 0. Now, if you're looking at a table, you can look for the point where x is equal to 0. Sometimes that point will be showing, sometimes it won't. If it's not showing on the table, you may have to extend the table to find it. So if they don't give you the point where x is 0, your best option to find that is to extend the table to find it. Now, if you can't do that, or if you're not given a table at all and you're given just some points, then it's also possible to solve for the b. Remember, the b is right here. By substituting a point in for x and y, and the slope for m, and then solving what's left. So if you know that your m is equal to 2, and you have a point at 1, 3, you would sub that in as 3 equals 2 times 1 plus b. So this is your y equals your m, your x, plus b. And then you could solve that to find your b. So when we talk about substituting like that, that's what we're saying. Take an x and a y coordinate, sub that in for x and y, sub the slope in for m, and then you have a little equation you can solve for b. So let's look at some examples of this. We're going to look at a couple with graphs, and then we'll look at a couple with tables, and then we'll look at some things with points. So in a graph, if you're asked to write an equation of a line, you've got to start out by finding your m and finding your b. Now in a graph, usually the b is very easy to spot because it's the point where it crosses your y-axis. Usually you can see that, immediately identify it. So when I'm looking at this one, and I'm looking at, well, what's my m, what's my b? I'm going to find b first because b is that point where if this is my y-axis, my line touches it right here. So my y-intercept, my b, is going to be 10. Now the point is actually 0, 10, but you just give the y value to be able to put it in the equation as the b. Now to find the m, we've got to rise and run to find our slope. So to rise and run, you pick any 2 points you want to, and it doesn't actually matter which 2 you pick. They just have to be points from the line. So I could pick these first 2. I could pick this one and this one up here. I could pick this one and the very end one. And as long as I pick 2 points on the line, I can count the rise and the run for it and then calculate with that my slope. So I'm going to pick these 2 just so we can see it. And I'm going to rise from here to here and from here to here. So I'm rising and then I'm running to get from one point to the next. So you can only move vertically or horizontally. Now, I know that maybe last year y'all moved horizontally first and then vertically. I always go up and over. If you go the other direction and you draw your triangle this way instead, that's fine. Just make sure you remember that the rise part gets divided by the run part. So it doesn't matter to me which way you do it. So looking at this, if I look at how far I had to go up, you might look at that and say, well, they went up 1. They did go up 1 block. But the blocks represent from 15 up to 20. So which means this space here doesn't represent 1, it represents 5. And then when I run, I'm going from here to here. It looks like 1 block, but if you look at what they represent, it represents going from 10 to 20, which means the run is valued at 10. So then I divide that, the rise divided by the run. So 5 divided by 10. Gives me a slope of 1/2 or 0.5. You can give it as a half or you can give it as 0.5. Either one is okay. So once I calculate my m and calculate my b, I put those together to make the equation. Y equals, that y came out crazy. Y equals 1/2 x plus 10. Or y equals 0.5 x plus 10. All right, let's do another one. This one, same thing. We're going to write the equation of a line for this graph. And this one is a little bit different looking because it doesn't give us points like the other one did. So if I want to find my m and I find my b, I'm going to look for my b first by looking to see if I can see where my line touches the y-axis. So here's my y-axis. The line crosses it right here at 2. So I know my b value is going to be 2. Now to be able to find slope, I've got to find 2 points on the line that I can rise and run between. And if you had me for foundations, you remember me calling these stop sign points. Because we're looking for points where 2 grid lines intersect each other, so that we can see exactly where the line touches. So when I look at this and I think about stop sign points, here's what I'm talking about. If I'm traveling up this line, do you see how right here I have this grid line intersects that one? And so I have a perfect stop sign point that would exist right here. And if I keep going up the line, I can keep traveling. I can see that another one exists here. Another one exists on my y-intercept. And there's another one here. And then technically there would be one at the very ends of each of those arrows because you can see where they would be crossing at that point too. So this line really has 6 points I could use to figure my slope. Now, I'm obviously only going to use 2 of them because that's all you need, but there's 6 that you could choose from. So I'm just going to go with these 2 right here. It does not matter which ones you use. So if you use 2 different ones and you want to try that, it's fine. You'll still get the same answer. So for this one, if I look at what I'm counting by, 0. Now, my next number is 2, or -2, whichever direction you're going. But notice there's a line in between, so they're really counting by ones. They just labeled every other one. 1, 2, 3, 4. And going up and down is the same thing, right? 0, 1, 2, 3, 4. So they're still counting by ones. Every square is worth 1. So when I go to count this, I went up 1, 2, 3. And I count that like this. I start here and I go 1, 2, 3 lines. So up 3. And then I run 2. So to calculate my slope, rise divided by run, 3 over 2. So my m is going to be either 3 over 2 or 1.5. You can give that either way. So, sorry, I think I paused that. My equation is going to be 3 over 2x plus 2 or 1.5x plus 2. Either one. That's the same exact equation. Now, if you want to check yourself and make sure you're right, you can always graph the line that you create and make sure that the graph looks just like the graph you were trying to recreate, or you're trying to create the equation of, and that'll tell you whether you're right or not. All right, next. Now let's look at this from a table perspective. So if they ask you to make a table, or to use a table to make a graph and write an equation, it says make a graph, but we're not going to graph that. You could graph it in Desmos, but we're not going to do all that right now. We're just going to write an equation from it. So again, to write an equation, I got to have an m and a b. Sometimes the table will give you the b. Sometimes it won't. So if I look at this one, I'll know the b if I can see the point where the x is 0, because that's what a y-intercept is. It's the place where the x is 0. If I look at this, I do have a point where x is 0, 0, 4. So I know the b value for this is going to be 4. Now to find the m, I could graph this table and then rise and run between the points. Or I can use the slope formula that we were talking about, where you find the change in your y and you divide it by the change in your x. So if I look at that, I'm going to look at how's the y changing and how's the x changing, so I can then see how much my change is for both. So from 4 to 6 is an increase of 2. From 0 to 2 is an increase of 2. So I would divide 2 by 2 and get 1. Now, I have a lot of students who look at that and they say, well, it's changing by 2 right here, but it's not changing by 2 down here. How can it be the same thing? It is. 6 to 9 is... I muted myself, sorry. 6 to 9 is changing by 3. 2 to 5 also changes by 3. If I divided 3 divided by 3, I'd still get 1. And if I did the same thing here, from 5 to 8 is 3, from 9 to 12 is 3. 3 divided by 3 would still be 1. 12 to 16 is 4. 8 to 12 is 4. 4 divided by 4 would still give me 1. So no matter which points I use, I'm still going to get an overall rate of change of 1 because it's consistent all the way through. So if my m is 1 and my b is 4, my equation will be y equals 1x plus 4. Or you're more likely to see that as y equals x plus 4. All right. Let's do another one with a table. So this one asks us to write an equation for this, or didn't ask us that, but that's what we're doing. I'm going to use it for that. So I got to find an m and a b. Again, I always look for my b first because it's the easiest thing to spot usually. Now this table does not give me a point where x is 0. It starts at 3. So it goes from 3 to 4, 6, 8, so on. So if I need to figure out the value where x is 0, if my x is at 3 right now, it's pretty easy for me to back it up to 2 and then to 1 and then to 0. So I'm going to do that. Extend my table backwards. So it counted up 1 going to the right from 3 to 4. So I'm going to be able to count back by 1s to keep that pattern consistent. And so since this went up 1 and this went up 1, that means if I back up, I can go back 1 each time. So if I was at 5 and I go back 1, I would have been at 4. Back 1 again puts me at 3. Back 1 again puts me at 2. So this is my y-intercept, 0, 2. So 2 is the B. Now to get my x, again from the table, the best way to find your slope, is to do the change in y divided by the change in x. So I already looked at this and saw that my y changed by 1 when my x changed by 1. And 1 divided by 1 is 1. And you can see that again right here if you look from 6 to 8 was a change of 2. And from 4 to 6 was a change of 2. 2 divided by 2 is still 1. So y equals 1x plus 2, or y equals x plus 2 would be your equation for that table. All right. I'd like you to take a minute and pause this video, and I want you to try the 2 on this slide with the graphs and the 2 on the next slide with the tables. Figure out your M and your B and put that together to create your equation, and then come back and see if you were correct in that. So pause it, try those 4, and then come back and see if you were right. Okay, so take a look at these and see if you got the same thing that I got for your answers for the equations of each of these. So you can see if you missed any parts of it where you can look back and see what I got for slope and where I marked the y-intercept for each one. One thing to point out, make sure that you put this as a negative 3 over 5, because this line is slanting downward, which means its slope would be negative. So if you didn't put it at negative 0.6 or negative 3 over 5, then you need to make that adjustment there. All right, pause it if you need to get any of this worked out, or check yours even closer because you missed a part of it. And then for this one, you should have gotten these as your equations. Again, for getting the slope from the table, you divide the change on the y by the change in the x. And this one wouldn't simplify, it would have been a crazy fraction, so we left it, or crazy decimal, so we left it as a fraction. This one simplified to -2, so I put it in as -2. I had to extend the table back here. So since I went up 2 and went down 4 on this side, I went back 2 and went up 4 on this side to make that adjustment. Okay. So let's keep going and look at some of this now with points. So if they ask you to write the equation of a line that passes through some points, and you're going to see this a lot, or often on the ACT, this comes up quite a bit. So the first thing you need to think about is, okay, to write an equation, I got to have an M and a B. Now you could potentially graph your points and try to find where your y-intercept would be and what your slope would be by rising and running from those points. But you don't have to do that. You can do other things too. So if I look at these 2 points that I'm given, one of them represents my y-intercept because one of them starts with an x value of 0. So this point right here is my y-intercept. They don't always give you a point that is, but sometimes they will. So that tells me that I already know my b is -3. Now they don't give me an m, so I'm going to calculate my m using that slope formula. You don't have to write this down, but remember, slope formula is y2 minus y1 over x2 minus x1. So I'm going to fill that in with the values from my points. So my second y minus my first y. So always subtraction, by the way. And then my second x minus my first x. And I'm going to calculate that. I can push the fraction bar in my calculator and type this in just the way it looks. And it will give me a simplified answer for my slope. So negative 3 minus 4 is negative 7, over 0 minus 7 is negative 7. Negative 7 over negative 7 is positive 1. So the equation of my line is 1x minus 3, or just x minus 3. Okay, let's do another one. Here's one again where we're going to write the equation of a line that passes through these points. We want to look at our points and see if any of them are y-intercepts already. So I've got this one and this one. This one is my y-intercept because it starts with 0. Anything with the x value of 0 is a y-intercept. It's a place where it crosses the y-axis. So I know that the b is 5. Now I'm going to have to calculate my m using that formula. So y2, 5, minus y1, 1, over x2, which is 0, minus x1, which is negative 2. And that's going to give me a slope of 2. Again, you can calculate that with your calculator. You do it piece by piece. I get 5 minus 1 is 4, 0 minus negative 2 is 2. 4 divided by 2 is 2. Okay, so we've got our m, we've got our b. Put it together into y equals 2x plus 5. All right. Now let's look at some where they don't give us the b as one of our points. So neither of these points starts with a 0, which means neither one of these is our y-intercept. So that means we're going to have to solve for both. To be able to solve for the y-intercept, you have to first know a slope. So we're going to start by finding our m, and then we're going to use that to find our b. So I'm going to set up my slope formula with my subtraction. I'm going to plug my numbers in. So y2, negative 3, minus y1, 4. x2, 4, minus x1, negative 2. And I get negative 7 over 6, which is a weird number, but anyway. So that's my m. Now, to be able to find a b, you have to know an m, and you have to know a point, at least one point. Doesn't matter which point you use, but you got to use one of them. So I'm just going to use negative 2, 4, because it doesn't matter. So I'm going to take my point, and I'm going to take my slope, and I'm going to plug those into y equals mx plus b. You don't have to write that up there. I just want us to think about it. So that means where the y is, I'm going to put the y value from my coordinates. So I'm going to put the 4 in place of the y. 4 equals. Where m is, I'm going to put my slope, which was negative 7 over 6. Where x is, I'm going to put the x value from my coordinate, negative 2. And I'm going to leave plus b in the equation because I need to find b. That's what I'm looking for. So I've created an equation now with a variable, and I can just solve for that variable. So I'm multiplying negative 7 over 6 times negative 2. And that's going to give me 14 over 6, which will be 7 over 3. And then I'm going to subtract 7 over 3. So I multiplied this, subtracted from both sides. 4 minus 7 over 3 will be 5 over 3. So my b is 5 over 3. And so my equation, negative 7 over 6x plus 5 over 3. All right. Let's look at another one like that. That gets a little bit tricky. Not terribly difficult, but a little bit tricky. But this will be another one. Same thing. We're not going to be able to look at it and be able to know our b right away because we don't have a point that starts with 0. So that means I got to solve for both. Got to find m first. Pause the video for a second, and then set this up and see if you can get a correct slope. Then unpause it and see if you were right. All right, see if you get a slope of -1. 3 minus 7, 3 minus -1 gives me -4/4, which is -1. So I've got my slope. I'm going to solve for b. Again, by using y equals mx plus b. Now, I'm going to use this 0.33 this time, because that makes this really easy. 3 equals -1 times 3 plus b. And I'm going to multiply -1 times 3. Add 3 on both sides. And I get b is equal to 6. So y equals -1x plus 6. All right. Now, what if they give you one that they give you the slope? So this time they gave us m. And they gave us a point. They don't give us b. So we're going to have to solve for b. Take a minute, pause this video, and see if you can set this up with the correct m and the correct information in for x and y and solve it for b. Then come back and see if you were right. All right, so hopefully you solved that and got a b value of -2, which means your equation should be 2x minus 2. All right, one more thing we got to look at is parallel and perpendicular lines. So if they ask you about lines that are parallel, you need to know that those lines are always going to have the same slope. So if one has a slope of 2/3, one that's parallel to it will also have a slope of 2/3. Now, perpendicular lines, that means they meet at a right angle. They're different. They're going to have a slope that is called the opposite reciprocal. And that's mathy sounding. So opposite just means if one is positive, the other one's going to be negative. If one's negative, the other's going to be positive. Reciprocal means you would flip the fraction over. So if you had one that had a slope of 2/3, one that was perpendicular would have a slope of -3/2. So I flip the fraction and I change its sign to make it perpendicular. So if they ask you to write the equation of a line that's parallel or perpendicular to another one, you just use the slope from the other equation as the slope for the new, or to figure out the slope for the new equation, then find the b and write the equation with the slope and the b that you know. This comes up on ACT. They almost always put something about parallel or perpendicular lines on ACT. So let's look at this. So here's an example. They want us to write the equation of a line that goes through the point 4, 2 and is parallel to y equals -3x minus 5. When you see this word parallel, you need to instantly think same slope. So if I identify the slope in this equation as -3/4, I know that my new equation is going to have a slope of -3/4 to be parallel to that original one. So I already know my m. Now, I don't know the b. The b from this equation over here doesn't matter to me. It doesn't matter that this goes through -5. It makes no difference. What does matter is that I need a line that's got a slope here that goes through this point. So I'm going to use this slope and this point to find my b. So 2 equals -3/4 times 4 plus b. So I'm subbing those parts into y equals mx plus b. Y, m, x. Looking for b. So I'd multiply that, get -3. Add 3 on both sides. And I'm going to get that my b would be 5. And so I can write an equation just like that. All right, let's do another one. So this one asks us to write the equation of a line that's perpendicular. That means opposite, right? So I'm going to look at this equation, find the slope, and then create a slope that is opposite for my new equation. So I know the slope of this one is 3/4. So the equation of my new one will have a slope that's opposite that. So instead of 3/4, I'm going to write 4/3, and I'm going to make it negative. And then I've got to think about the point it's got to go through. Now, this looks like it could be a y-intercept, but it is not. It does not start with 0. It ends in 0, which makes it an x-intercept. So I'm going to have to use that point and this slope to find b. So 0 equals -4/3 times -4 plus b. So multiply to get 16/3. I'm going to subtract 16/3. And so my b is -16/3. Which means my equation would look like that. All right. Take a minute, pause this video, see if you can come up with the m and the b and create an equation for a line that would be perpendicular to this one. Now, I will remind you that 2 by itself is really 2/1. So when you go to flip it, that gives you something to flip to create your perpendicular slope. So pause the video right here, try that out, and then unpause it when you're done and see if you are correct. All right, take a look at that and see if you got the same thing that I got. So with my slope, I took my 2/1, flipped it, and changed its sign. And then I used that to solve for b by subbing in my 5 and my -2 for x and y, and then calculating all of that to get a 1/2 for b. All right. So the next 5 questions are test prep style questions. So I would like you to take a few minutes, work through those 5, and then come back to these slides and see if you were correct in the answers that you got for them. Please actually take the time to pause the video and work them out, because practicing this will help you make sure that you know what you're doing. And just writing down my answers doesn't really help you with that. So take a few minutes, try these out, and then come back and see if you were correct with those. All right, let's go through these and let you take a look at what you got. So for the first one, you should have gotten -3x plus 4. If you missed that, pause the video and take a look at how I calculated my slope, where I got my b, and see if you can figure out what you did wrong there. For this one, you found your rate of change to be 1/2. The only one with that was option C, so that's why I chose that. For this one, to find your rate of change, you would have to rise 1 and run 2. And so since it went up by a single block, we knew that that run part had to be counting by 2. So the x's counted by 2s, the y's were still counting by 1s. For this one, you calculated your rate of change, you got 5. The only one with a rate of change of 5 was the first option. And for this one, I would have done this one in Desmos, and I had this pulled up so I could show you what happens. But if you graph them in Desmos, you're looking for the one with a slope of 10 and passes through the point -2, 5. And actually, C and D both do that. But the one that is in standard form, and we haven't really talked a lot about standard form, but standard form has whole number values for x and y, and your x has to be positive. So this is not standard form because the x is negative. This is standard form because the x is positive. So this bottom answer choice is your answer for that one. All right, that is the end of that lesson. Y'all go ahead and submit those notes, and then there's a graded practice ready for you to do. Have a wonderful day. Thank you.